Hello, and welcome to The People's AI, presented by Vana. I'm your host, Jeff Wilser, a journalist who covers the intersection of crypto and AI for CoinDesk and alike. And I am delighted to be joined today by Nic Lane, the co-founder of Flower Labs, who is also a deeply credentialed scholar and professor studying federated machine learning at the University of Cambridge. We had a fantastic conversation about what federated AI learning is, how it works, why it matters, and how it can make actually cooler AI. And I am proud to partner with Vana to bring you this podcast. Vana's mission is user-owned data to help create user-owned AI. And as it happens, Vana recently announced a collaboration with Flower Labs, and Nic and I get into that and what it can mean for the future of AI. Spoiler alert, it could create wild new use cases that are simply not possible in today's world of centralized AI because those centralized models just don't have access to the right data. So anyways, back to Nic. He has been studying the technical ins and outs of how to build decentralized AI, or you can call it federated learning AI, and Nic and I do get into whether those two things are precisely the same thing, kind of, sort of. Anyway, he's been studying that space for roughly 7 years, or way before it became all the rage in crypto circles. His knowledge on this is as deep as it comes. And here's what I think is really interesting about Nic's story. There are many in the Web3 plus AI worlds who, kind of on principle, see big tech AI as dangerous or somehow problematic. So they've come to embrace and focus on decentralized AI on more or less ethical or principle grounds. With Nic, he has a rather bold premise. Years ago, he made the bet that decentralized AI could create better AI than a centralized version, period, full stop, not even thinking about the principle side of things. One of the main reasons why he's making this bet is he figured way back that when you create AI in this centralized, massive data center fashion, well, eventually you are going to run out of good data. So Nic thought that a distributed system of AI can ultimately, when we work out all the kinks, hoover in richer data and create more novel types of AI, such as better healthcare AI or even better weather forecasting AI. We get into all of this in detail, and Nic does a great job of laying it out in terms that work for both newcomers and pro users, if you will. So with that, please enjoy my conversation with Nic Lane, the co-founder and chief scientific officer of Flower Labs. Nicholas, welcome to The People's AI.
Hi, thanks for having me.
So love to hear more about your area of research and focus and Flower. Tell us about what you're focused on in Flower.
So I think Flower is all about trying to make federated AI mainstream. And so Flower is an open source framework and platform. It's been around for 4 to 5 years now, built up a large sort of following of developers and researchers. And I think our big epiphany was that centralized forms of AI and decentralized forms of AI could really just be equally easy to use and simple. It's just that we lack the tools and frameworks on the decentralized side to make that possible. And so there's sort of this a feeling in the community, both in terms of research, practitioners, developers, that decentralized forms of learning are much more difficult. And then we realized that it was really the difficulty was based on the weakness of the frameworks. There really hadn't been enough investment in that side of things. And so that's why Flower came into existence, and that's where it's kind of pushed forward. We've always been striving for the developer experience and trying to...
in other words, it's not like there's some a priori reason why decentralized AI is harder. It's more there has not been as much investments in those systems and tools. That was kind of
that's the view that we take. I mean, maybe jumping too far into it. I mean, just to take one step back and to define these terms a bit more clearly for folks who haven't seen it before as much. So right now, mainstream AI is all about centralized forms of learning. And so what that means is that we have all this discussion and this infrastructure being built around data centers. because we can't train models under centralized algorithms unless the data and the GPUs, the compute, is all in one place, and
Co-location,
that's
right?
co-location, right? So then, for us to build, any sort of model from ranging from ChatGPT down to sort of more smaller models we've had back historically, like LXNet and so forth, there's always been the need to have the data you're training on and the computation all in one physical place.
Mm-hmm.
And so that kind of characterizes all of AI right now.
Yep.
And so there is, it turns out there's an alternative way to do this. It's been around for a relatively long amount of time. Around, say, 7 years ago, people invented a form of learning called federated learning. And so federated learning is an approach where the computation and the data can be in different locations. They can be connected with slow links. And it has, and once you have that as your starting point, you can build these machine learning systems, this machine learning infrastructure in very different ways. And so the way that it really took off was that people realized,
Is it
yeah,
fair to characterize, is federated learning, is that roughly the same thing as decentralized training? Is that a
yes, yeah, I
fair?
think definitely, definitely. I mean, I think what's happened in the last few years is interest in decentralized learning of all kinds has taken off.
Mhm.
And so we're having there is now a variety of a spectrum of techniques emerging. And there's also a little bit of uncertainty about what terms we should be using.
Yeah.
And so and in my mind, these terms are approximately interchangeable. It
Okay.
depends how technical you want to be. So some people might decide that federated learning is a particular kind of algorithm and it's distinct from decentralized. Some people might think that decentralized has to be coupled with ledgers and different things. People have different perspectives
Mm-hmm.
on these issues, but I think the important piece of information is that they are all alternatives to centralized forms of learning that is all centered around the data center. And that by following this path of decentralization, there's lots of other learning characteristics we can build into our systems.
I got.
So yeah.
I have 1,000 more follow-up questions on this. It's fascinating. Before we go down that rabbit hole too far, for orientation for listeners, tell us a little more about your background and area of research, and kind of what led you to, as you were studying machine learning, as you're focused on this, what kind of led you toward the insights that federated or decentralized AI makes the most sense?
So I'm a professor at the University of Cambridge, and I've been working with Daniel and Tanner for a number of years on federated learning. We built the Flower framework. We were excited about building, or basically allowing the style of learning to become mainstream and commonplace, because it then would allow the proliferation of a lot different forms of AI that currently is just too difficult to build.
Hmm.
And so we could think of this, for example, just from the application area. People might wonder why we see lots of chatbots, and then you might also wonder why you see a lot of image classification models if you can look at papers and so on.
Mhm.
And the
Mhm.
reason for that is that it's the data sets. And so the availability of data informs a lot in terms of what type of AI we can actually build.
Hmm.
And so the reason why we have lots of chatbots is that it's relatively easy to scrape the web. And so the
Yeah.
web has all this text, and so you can scrape the web, and from all of that data, you can build chatbots and language models and so forth, and start to build AI that way.
Mhm.
Another reason why we see all these image classification models that tell the difference between a cat and a dog and a car and so forth is that there are long-standing labeled data sets of millions of images.
Mhm.
And so what's important is that data shapes the AI that we have. And if we can migrate from a centralized sort of viewpoint to a decentralized one, we can start to access a lot of data that would be otherwise impossible or too difficult, or have sort of other kinds of constraints around it that we might otherwise want to build AI systems of that kind, but it's just too hard. And so the kind of classic one in this decentralized federated space is that of healthcare. There's a lot of siloed healthcare data and medical data and life sciences data out there in the world, but it is siloed. Some of it has a lot of privacy sort of attachments to it that you want to respect. And then it's fairly incompatible with a world whereby you must copy the data all into one central place in order for training to happen. You can do that on a small scale. So, you could have a company make an arrangement with a hospital. You can access that one hospital's data. You can have a company make, some sort of special one-off, access case to an organization that has a lot of data. But the idea of being able to access en masse data is just it's just not going to happen unless you can completely re-engineer the way that you're building these models. And so to kind of go back to what we were saying before, given that right now all the data and the compute needs to be centralized, and if you sort of look into that, what that means is that the organization running that infrastructure, running that GPU data center, needs to be able to say to the people who have data, "Hey, we're going to copy your data in. We're going to train that model." There's a whole host of issues that come with that. So there's compliance issues. It's very, very hard to maintain privacy. It's very hard for the people who have that data to remain in control of it. It means everyone has to play a very fair game. Everyone has to be very highly trusted for anything to really happen. And so there's a whole host of issues. For one thing, it slows progress down. You only, there's a limited number of people who want to work with each other. People trying to train models to do with healthcare, for example, have to work with a lot smaller data sets. And so then where we see AI make, huge progress, we see it being made in image classification and language models. But I think if you ask someone on the street today, they would love to see AI taking off in various kinds of health verticals, being able to predict prostate cancer, being able to discover new drugs, and all these other sort of things that people want to see done, and even a much wider palette. AI applied to how do you schedule buses, how do you improve banking, how do you improve their everyday lives, right? You don't see that happen as much, and that's because of access to data is limited.
Nic, and just to underline this point, did I hear correctly that you began this journey and this kind of started following this North Star of decentralized or federated learning, driven by the need to get higher quality in different types of data than you can easily get by scraping? That you started this mission 7 years ago, like years before kind of ChatGPT and centralized AI took off. Am I getting that right? That is wildly prescient.
Well, so we started Flower 4 or 5 years ago, but federated learning as an approach was known about 7 years ago.
Yeah. And so you had back then, you had a sense, even though no one was talking about chatbots, no one was talking about these image generators and identifying cat, you had the sense, well, guys, if we look years from now, the low hanging fruit of data will all be plucked. And we need to find different types of data to develop richer, more robust, different types of AI. That was your North Star 7 years ago.
Well, I would say that. Well, I would say that it's been an interesting journey in the sense that when we started doing this type of learning, the type of models, the capabilities, the need for data actually was quite different. Back when we first started, it was actually more to do with having access to certain kinds of data to train specific models to do things. That was just too difficult. Even though we knew the algorithms were there, even though we knew certain things could be done, it was the difficulty in accessing data that seemed to be holding a lot of industries and a lot of sort of use cases back. And so that was the motivation. And then also simultaneously, there were these proven algorithms for training in decentralized and federated ways that had so far been used on fairly niche use cases, but we felt very strongly that they could generalize. And then what's been interesting is that if you fast forward a few more years later, now it's become even more important. It seems like every year that passes, this issue becomes more and more important because of things like foundation models, large language models, and now we're facing not only pressure in terms of data, but we're facing pressure in terms of availability of compute, which these methods can also help with.
I think that it's also worth pausing for a moment to note that it, if I'm getting this correctly, you went down this path toward federated learning, not driven by some ideological mission that centralized AI might create these powerful big tech companies that could have undue influence in our lives. Now, I don't want to put words in your mouth. Maybe that was part of it too, but it sounds like the reason I'm getting at is a lot of folks in the decentralized AI world, and especially in the Web3 AI, crypto AI worlds, are driven by almost this principle of big tech can get even bigger tech and will have even
Yeah.
more influence in our lives and can ultimately have influence in how we think, right? By controlling these models of, if eventually people, I think it's not a stretch to imagine that most people will be mainstream to have some kind of AI chief of staff or someone who is kind of delivering you instead of like, going something way back. It used to be we watch the NBC or Walter Cronkite to get the news, right? Then it kind of shifted to cable news, and it shifted to online and social media and so on and so on. And it's already getting more fractionalized and balkanized. I think the logical conclusion will eventually all have we'll get our news and media from our own personal Walter Cronkite, who sees the world the way we
Sure.
do and gives us, oh, here's what happened yesterday in, this country or whatever. Whoever develops those models can kind of develop the Walter Cronkite they want, right? And to get us to think certain ways. So long-winded way of saying there's so many folks who are going down this path of decentralized AI, even though it kind of on the surface seems harder, and we'll get into the obstacles and challenges in a bit. It sounds like though, Nic, what I'm getting at is you went down this path largely because like putting aside principles, I'm not saying you have its take there either way, but even just objectively putting aside all that purely to create better AI, to create different types of AI, to
Yeah.
incorporate data. That's why you went down this federated learning path, which I think is really that's really interesting to me that you found it like on the merits of it, not just because of principle,
No, totally.
but the merits themselves justified this development of this tech. Am I getting that right?
Totally, absolutely. I'm not sure how these things will evolve
Yeah.
moving forward, but I think there's a very strong case to be made that AI needs to become federated and decentralized in order for its progress to continue. I think we can see distortions of the technology perhaps for a while longer, maybe for quite a while longer, if you kind of if you have enough money and you have enough incentives, you probably could keep things going as they are for a while longer.
Mm-hmm.
But I think there is actually a much better operating point for this technological landscape that is there's something much closer to the internet. I think, and so Daniel, my co-founder, he has this nice way of framing things where he talks about the AI that we see right now is a lot closer to the sort of mainframe
Yeah.
era of AI. So back in the 60s, we had IBM, big mainframes, because everything, it's a very strong analogy. It's strong parallels there because the data center that we're building, data center sort of infrastructure we're building right now, looks a lot like a mainframe. You have to copy data in. There's no real thought put into how do you have interoperability,
Mm-hmm.
how do you share resources, so things that are very natural in computer science, where you share networking resources, data resources, storage, compute. It's very natural to share resources very elegantly based on the fluctuations in demand.
Mm-hmm.
Whereas that totally doesn't happen with AI right now. That's why you hear things like where a company like, say, Elon Musk wants to train some giant model. They say, oh, how many parameters is that model? Oh, it's X number of parameters. Oh, that means I need to have, 100,000 GPUs. So my next job will be to, order 100,000
Right.
GPUs and install those GPUs. That's crazy. Normally what happens if you want to do something at scale, you just say to yourself, oh, well, how do they, what resources are available to me if I need to do one job, one process to train, one model? Well, then I will, rent those resources, borrow those resources. I will timeshare those resources. That's the way the world works.
Right.
That's how you have high utilization of resources, and it's not the way that we're going down in terms of a path for AI right now. But again, it's all premised, I think, on the fact that for a lot of people, even fairly technical people, they don't realize that there is a very possible alternative. They don't even realize that the data center centric training is has an alternative. They don't realize how easy it relatively is. And then B, they don't even often see the benefits that will come if we push it further and further.
You mentioned how easy it is. I think that a lot of casual folks, like me, certainly, and very casual here, might raise their hand and say, "Wait a second, but easy." I thought that, as you said, the primary way AI is being trained, developed right now is in this kind of like centralized, get as many GPUs as possible in one place, big data centers, and then combine, you have your GPUs, you have your data, and you just scale that and make it larger and larger and larger and larger, and voila, the LLMs get better. My understanding is there are some very real technical advantages of having things all in one place, right? By having a big warehouse full of GPUs that, like, for one, latency, right? If we're trying to,
Sure.
where are you based again, Nick? Where are you based?
So I live in Cambridge, UK.
Okay. So Nick's laptop in the UK, my laptop here in Denver. If we're somehow trying to in this decentralized federated way, train a model with the UK laptop and Denver laptop, that just creates certain physical challenges and handicaps that we overcome. So
Sure.
That's the kind of layperson like myself skeptical question. How does to what extent is that a real barrier has to be overcome and a challenge? And B, how do you guys overcome that? How does federated learning seek to work around what seems like a pretty tricky physical constraints?
Well, how do I approach this? So I think it's important to notice that those challenges are real. And so then when you have latencies between resources, they need to be factored in. There are learning algorithms that are evolving, that are emerging, that help us manage those issues. And so just a very basic vanilla approach to learning is in a federated or decentralized context. What you'll do is you'll have compute and data that's isolated from each other. Then you'll have that local piece of machinery try to extract out the information from its local data as much as it can, and it'll start to create. I mean, there are different kinds of algorithms. So I'm trying to think what level of abstraction to talk to.
Sorry, I mean, still here, but just when you say a local machine extract out, you mean there's some on my laptop, there's some algorithm that lives locally that's trying to curate and extract the relevant data that will eventually go into feed AI. So it's on my machine, things are happening.
Yeah, exactly. Yeah. So you can think of this as being there are two timescales you can operate on. You have the ability to access your data locally, which is very, very fast. And then you have the ability to communicate that data to other nodes, to other pieces of the network, and that's relatively slow.
Yep.
And so your ability to learn from your local data can be relatively fast, can be very fast, in fact. And so, but the ability to transfer data between the other nodes to kind of collect that information can be much slower. And so say if you have, depending how these, depending on the topology you're trying to learn on, those two factors can either be, much more pronounced or much smaller. So imagine if we have a network of, say, 3 nodes, where each node, maybe they're hospitals, and maybe that each hospital has access to quite a lot of data. So they can locally learn from that data at a very fast rate. And then they could be exchanging in clever ways sort of partial information between each other to kind of converge to a final model, a final global model that understands information from each of the sites. But there's no need to transfer all of the data. There's not even any need these days. There's no need to transfer all of the model weights between each other. You can find ways There are different sort of algorithms that can exchange just the important pieces of information that has been distilled from that data, that needs to be exchanged between these nodes in order to come up with one single model that's very powerful. So I'm
Interesting.
not, yes, I'm not sure
No.
how technical your audience is and how far you want to go down that path. But but I think one way to think about those is there's always two timescales at work, and depending on the topology, there can be other ones too. For example, sometimes you have sites that just have data alone, have very little data, and then you might have sites that have compute only, and then the connectivity between those two sites can be very influential on the training side as well. But another sort of data point your audience might be interested is depending on how you measure these things, and academics and researchers love to fight about numbers and like fight about what's the right algorithm, so forth. It's a lot of fun and games. It's all great, but I'm saying, but depending on how you look at things, it's very reasonable to say that in the last 12 to 18 months, there's been 1,000-fold improvement in our ability to train distributed, decentralized models and reduce 1,000-fold reduction in the amount of data that needs to be exchanged over these slow links. And so there's massive progress being made in how you can train models and overcome what is the primary bottleneck, which is the slowness of links between these nodes. So there's that side of it. So the challenges are very real. But one thing I want to point out is something that people often neglect, which is external factors to this. And
Yeah.
so one of the external factors would be if I have a set of GPUs, and yes, I can train very quickly on the data that's available in that data center, but I might have very limited access to a lot of data under that setting. So I might, perhaps I can train a model very fast. Maybe I train it in 12 hours. It's a fantastic
But if
model.
there's no
Yes,
data, then great. I have this really amazing car, but no fuel to run it. So what good is it for you?
exactly.
Right.
Exactly. There's that whole argument there. And so that's a very real argument because, if you're trying to build these serious models where data is difficult to access, yes, maybe I can describe to you a decentralized network, maybe of 1,000 nodes around the world that has access to, perhaps it has access to like 100,000 more data times more data. And so,
hmm
yes, perhaps it might take 30 or 40% more time to
hmm
converge a
hmm
model. But that model is so strong, and you'll want to spend that 30% slower wall clock time in order to get that model, or maybe even double. These things are highly dependent on the network, highly dependent on the ratio of data to compute in the local node. But my point would be that there is a plethora of algorithms coming that let us manage these sort of like hard technical issues. And on the flip side, our ability to access more data is just going to be long term this unfair advantage that these decentralized models are just going to have, and the gap is going to get larger and larger and larger and larger, and it'll be on every single front. And it'll be most pronounced on the fronts where data is less readily available. And so, those models are the most valuable in my mind, because I think we're seeing a commoditization of models that are based on web-based data. I think you're going to see, it's already happening as far as I can see, that open weight models of various levels of openness
hmm
are sort of saturating in terms of the benchmarks. There might be some clever ideas like self-play and reasoning that come along, but all those techniques are probably going to just like normalize across the landscape. And then the real big differentiations will be on ability to access data, and then ability to train on that data. And so, do you have the right algorithms? Do you have the right software? Do you have the right network? And then, do you have the right sort of data network underneath that? That will be fairly unique.
Well,
That will be the
that is
interesting pieces of models.
that was an amazing primer of federated learning. So thank you. And that brings me to something I'm very curious about as far as needing these models, needing data, and the models you're building um, structurally being more open to gathering different types of data from the edge, from different industries, from healthcare, and so on. Um,
Mm,
Nick, and that gets us, of course, to the collaboration with Vana.
yes.
Uh, I'd love to hear more about that, but maybe to bigger picture to bring us there. Um, as an academic, how are you thinking about the realities of, okay, like, is the average person going to give a big tech company, here is my healthcare record, here's my patient records, or a hospital doing that. But they might, if there's some cryptographic way to do it in a way that preserves privacy, they might, if it's all done locally. So I guess my two-part question is, where, in your research mode as an academic, to what extent are you thinking about the realities of how like marketplaces work and how culture works and how human beings might be nervous of sharing data in one context but are open to sharing other contexts? And then realities of, do they need to get compensated? Do they need to get like a token, or how will it actually work as far as like contributing data to these federated models at the edge? And then love to hear a little more about the Vana collaboration and how that all works.
Yeah, well, so I think the way this plays out, I think we're going to be more technically able to train these models faster than we're able to build the right sort of infrastructure to make sure that to make sure society is ready to compensate people appropriately, and we've established norms of that kind.
Mm-hmm.
I mean, there's a way to think about it, I think, is that we have learning algorithms able to train under various settings, whether it's 1,000 nodes around the world, or it's just 3 or 4. And depending on what sort of bottlenecks we have, we'll be able to train models of that kind. Then, partnerships will form between organizations to share that data, and they'll probably start with organizations first. Although, through Vana, we're seeing a much more grassroots push
Mm-hmm.
to what's happening as well. So maybe it'll be, top and bottom down simultaneously.
Mm-hmm.
And then the missing part, I guess, from where I sit, is what Vana actually provides very strongly, which is kind of like a data control plane in terms of accounting for where the data is coming from, and then to some degree also ensuring that the right sort of work is being done at each of these nodes, and then ensuring that they're sort of functioning in a very secure and private manner to make sure the work is being done as expected. But use of distributed ledgers and these sort of technologies are perfect for being able to to properly account and with very high visibility about who is contributing what sort of data.
Mm-hmm.
What is I guess when I talked a bit about society, there's a lot of options on the table for
Yeah.
exactly how you want to reward people or
Yeah.
reward organizations for the data, and so it's relatively complicated. But what we need to but what we need to decide on is how we want to do that. And let me give you an example. You might easily have an organization or an individual that has a huge amount of data, but that the amount of interesting information, unexpected information
Mm-hmm.
in that data could be quite low.
Mm-hmm.
And on the flip side, some people might have small data points, 3, 4. It could be surprisingly little data, but that might be critical, highly
Can you give
informative
an example,
data
Nick,
that.
of what that might look like in either side, or just a basic example of what that could be?
Sure. So I guess in the imagine if you have imagine it's self-driving car data,
Yeah.
and then you have tons of data flowing in from New York City, and lots of people live there, lots of people driving there constantly, and so the information about certain ways that people drive, or if it's visual, what a street looks like, and so on, is fairly relatively commonplace. You can get
Mm-hmm.
that from many sources.
Mm-hmm.
Maybe New York is quite uniform in terms of how driving happens, and so perhaps the information available and the value of that is quite low. And then so you might have information from a very irregular location, maybe in a small town, maybe with some sort of idiosyncratic sort of ways of driving,
Mm-hmm.
that you could get from perhaps an individual driver, or you could get it from an organization that runs a taxi service in that town. But that could be highly interesting. It could be like, hey, look, did you know that sometimes these deer run across the
Right.
street and you should stop for them, all these sort of things, right? So
Right.
very relatively rare piece of information.
That's great. Thank you.
Yeah, so then I was just saying that how do you reward people based on volume, or reward them based on surprisingness, or the value of the data points themselves, is sort of a question. there is questions about what's the ratio of data to compute. So, for an individual might have a lot of compute available, it's idle, and they might be physically close to a data source. Maybe they live in the same town, or for some reason, the network fiber between them and some data source is really fast. And so the value of that compute actually could suddenly spike up for that reason. And so all I'm saying is that we have methods of building reward systems based on technology we have. The question is, what is the right way for that to be built? It's sort of open.
Yeah. So it sounds like one possible path forward is this the collective one partnership with Vana. Talk a little more about what that is exactly and how it works.
Sure. So I guess to unwind, Flower has been very interested in being able to show that federated decentralized models can be trained. There's, as mentioned before, there's some skepticism about the quality of those models, the feasibility of doing training of this kind. And so we were the first to train a 1.3 billion parameter LLM based on just regular data that you have, scraped from the web. We did experiments where we positioned the data around the world. We used compute that was based around the world as well, using slow links, and showed that with sort of under reasonable expectations of training time and so on, you could train models of that kind. And we showed that those models are just as good as the centralized varieties. And we did that a number of times in the last 12 to 18 months, scaling from 1.3 to 7 billion. We've been doing training runs lately of 13 and 20 billion. So basically we've shown that this sort of a pipeline.
That is astonishing. Nick, so actually, let's pause there for a moment. Can you go one? I think we've covered kind of big picture how this works and why it works and why it's important. If you can drill down one level lower on the tech side and talk about how Flower works and how are you able to, that's an astonishing result you just revealed. What is, kind of give us the basics of how the actual framework works?
Oh, sure. So the actual, using Flower, you could do what I've just described. The code I'm talking about is experimental, but anyone could train that just as easily as someone who wants to train on 10,000 GPUs today. Right now, I could grab someone, I'm in Boston right now, I could grab someone off the street, put them in front of a laptop, show them a nice NVIDIA stack, and then they can literally train a model on 10,000 GPUs, no problem at all. And so what Flower enables to be possible to do is train that sort of situation in a decentralized way. And so we started by having, I think, around 8 different nodes around the world. We had H100, so fairly high, powerful GPUs at each location. We had these open source data sets that were already available for training LLMs. We divided them up and placed them around the world, sort of talking very approximately. And then we showed that with a few lines of code, you can use Flower with a few extensions that we call photons. It's basically this Flower. And if you want to train these huge models, could be foundation models, vision models, whatever, we showed you can train those models with the GPUs and the data being spread around the world. And so essentially what's happening is that, as I mentioned before, the GPUs have available to them locally a fraction of their data. They're doing a conventional learning training loop over that data, and then they're sending these partial updates to each other using a ring reduce. So they're lowering the amount of communication by operating in a ring topology, which is fairly unusual to combine. Those ring topology and those sort of ideas come from the world of data centers, where you're trying to minimize the overhead of networking all the time because they're a tightly synchronized system. Okay. So, you mentioned, so the whole reason that people build data centers with really high capacity network capabilities is everything has to operate in a very tight synchrony. And so all the GPUs are, the people, if you drill down to it further, this is not exactly true, but to the level that we're talking at right now, all the GPUs, all the data, all the nodes are in tight synchrony all the time as they're training. And so what happens in Federated and these decentralized methods, we allow the individual nodes to become quite heavily desynchronized. And so then the individual nodes are pushing ahead, training on their local data aggressively, doing lots of local loops, and increasingly becoming different from each other. And then on a much slower frequency, they will exchange partial information between each other to keep them in some sort of some level of synchronization, but at a rate that is much lower than you would see from a data center.
Is the idea that like that gives the disadvantage, that is there has to be some very clever machinations you're using to eventually partially sync them up somehow, but it gives them the freedom. It lets them, everyone's machine can work as aggressively as it possible can on their cadence. Maybe you get some advantages by maybe so-and-so's machine in Nebraska is really powerful. And if it had to artificially slow down to match the power of someone else's machine in Iowa, then you're actually losing efficiency. So you're able to let all the machines go as fast as they can. And even if they aren't perfectly synced up, eventually, not all the time, that'd be inefficient to slow things down, but there's some partial amount of synchronization that brings them all kind of roughly makes it compatible, but you're getting the advantage of really aggressive developments on each local machine. Am I warm there?
Yeah, totally. I mean, that's what we want to get to. And I guess the distance between, I guess, to be honest, we're sort of talking about the way we're talking right now is imagining some of the issues that you face have been overcome. And
Yeah.
so,
Yeah.
we basically, the end game of these types of networks is a really elegant sort of situation for using all of the resources. We have the individual nodes, they're loosely coupled, they're racing as fast as they can on the data they have available. And then you're just kind of keeping them just synchronized just enough. So you're doing that proportional to the speed of the links. And so the distance between what we're saying and what the reality is a bit uneven depending on the situation. There's a variety of different algorithms out there. We've been doing this for a while, but there's work being done in other groups too. But what's interesting is there's not that many groups. So if in any place in AI today, every other topic I could think of, there are literally, thousands of groups of like lots of smart people working on those problems.
Mm-hmm.
In this space of decentralized, where you're trying to work on the actual machine learning algorithm part of it, I think there's only about 3 or 4 groups in the world doing serious good work. And so we're one of them. There's some strong groups in Google DeepMind, for example, doing work as well. And so the way I see it is that we're all just trying to explore the space of how we can build these systems more effectively. And then they are informing, basically, they're enabling different kinds of decentralized systems to evolve. And so I imagine these will be deployed in time for doing, weather prediction models, for example, where you can imagine all of that data that we have historically is nice and static. You can put that in a data center, but you will never be able to put inside a data center, live streams from around the world of all the weather data, right?
Yeah.
So there are these like very fundamental kinds of machine learning systems that right now are impossible to build. So there's a weather one I think is great, but you can see how dynamic that information is, and you can see the difficulty, and also the volume of data is extreme. I think robotics, people are very excited about robotics right now. There's no way that you want to have a centralized robotic learning system. What you want to do is have all of your robots in real time learning from each other. When one makes a mistake, there probably will be in time there'll be laws that enforce. You wouldn't want to have a robotics company building a substandard, unsafe learning algorithm that was centralized, because you can imagine if one robot makes a mistake, you want to make sure that mistake can never happen again.
I believe, right? The Skynet is it.
Well, no, I mean that's all about. But this is all about intent, right?
I know.
Yeah, but yeah, but you're right.
Am I right then that and thank you for kind of describing how it all works. Am I right then that Flower provides this framework that now, as I hear you describe it, has proven to be competitive, just despite the apparent limitations of decentralization. You've linked these all together, and now you're achieving results that are competitive with centralized models. And then the Vana collaboration helps provide the fuel, helps provide the data that actually feeds the models. Talk a little more about how the kind of like how those Lego pieces snap together, how the data fits into this world.
Exactly. So one thing we've been really interested to take in terms of a next step is that, as I mentioned before, we're using data sets that are well known. You spread them across the world, and you do these sort of experiments where people can understand the models you're trained, but the data is the same data you'll find in the data center.
Yeah.
One of the next big steps for these models would be, as we show that they're actually capable of more than the centralized versions can do, and that will primarily come from being able to access data that you can't get into a data center.
Mm-hmm.
And so Vana is a great place to start for that. They pioneered all of these data DAOs, which also perfectly align with the philosophy that underpins why a lot of people are interested in decentralized. You know, we also think that it's important for these learning algorithms, for these systems, to be, you know, composites of organizations and companies and so on, because they're so important. Um, but you know, one place that we've seen these emerge fastest is in data DAOs, where people can come along. They can say, "Oh, I personally have a lot of data in LinkedIn. Let me grab my data from LinkedIn and place it in this DAO, and then actively decide how it should be used."
Mm-hmm.
And so, you know, Tesla data DAOs, Reddit data DAOs, X.com data DAOs. You know, I saw there's around 300 data DAOs that have been built. They're run by the people who own that data, who create that data. And then, so this is a perfect kind of marriage of where to take this technology next, because there's a critical mass of data there. And so we're working with Vana to stand up, increasingly more, powerful experiments using data DAOs, and seeing which of the DAOs want to participate, which of the DAOs would perhaps give us data that would be the most distinct from the data that you see already in data centers, to do demonstrations. Initially, these would be more or less demonstrations of the capability that decentralized models can have. So we're starting with Reddit. We're right now we're working on what we call so collective one is the eventual goal that we want to hit.
Mm-hmm.
Within a 12 calendar month period. We announced it at the Flower AI Summit. I guess it was about 3 weeks ago.
Mm-hmm.
So Anna, who is the creator of Vana and CEO of Open Data Labs, she came out and she made the big announcement with Flower to say, this is what our big ambition is how we're going to approach this. We're using this tech, we're using these data DAO methods, and we're going to come together. And so right now we're looking at, then that model will be called Collective One. But right now we're working on Collective 0.1, which is working right now with the Reddit data DAO, and conversations with them about how we can pilot this technology. We need to also be extremely careful with the privacy elements to it. So there's something that is kind of a somewhat, it's an orthogonal piece, the privacy aspect of doing this training. So you could do these distributed training things simply to scale your compute, simply to scale the amount of data you have access to. But depending on the type of data, you might need to mix in, as we would need to with this Vana DAO-based data, strong privacy protections. And so, so we're working with them to decide what are the right techniques to put in place. And there's always a spectrum of protection in terms of privacy and the utility of the model. And so what's the right place to put that sort of line? This initial collective 0.1 will be an exploration of just how powerful these models can be. We're using 0.1 as sort of this placeholder name because eventually we want to tap into all of the users of data DAOs within the sort of 300 network that Vana's built. Everyone who wants to opt in should participate, and that will be collective one initially, because we're working with just a few of the data DAOs to start with. We were calling it 0.1 to kind of denote the sort of early stageness.
Amazing. Nic, final question for you. Give us a prediction of a type of application or use for AI that will be possible thanks to this type of federated learning that would not otherwise. You mentioned weather models for one. And another example or two, maybe in a year, 5 years from now, if this all breaks right, if this kind of goes the way you want it to go, what are some types of AI that we can actually use for the benefit of the world that we wouldn't have otherwise?
I think personalized home robots that are actually like where the brain of the robot sits in your garage. It would be a really important sort of outcome that we can easily get to, because that would mean that any robot you are working with would be driven by an AI that is you have full control over. So I think home robotics. I think all of this agent stuff that people are so excited by. You mentioned before the ability to sort of like determine the news, figure out what's important to tell you, understand that those are the more passive collections of data, but they're very important ones. So you want to have that under your control. So, personalized agents understand what's the right information to give you, and then also are able to make all these decisions on your behalf. That's a great vision, but those models, I think, will become, powered, running on your laptop, running on your device, fully informed by, your complete history of data, but you're very comfortable with that because it's completely under your control. I think whether all of these natural phenomena data, I think healthcare as well. So rather than having to sort of, have data that's trained from, large amounts of data where that data doesn't have a lot to do with your own personal sort of makeup, you will be very comfortable with predictions that are tightly coupled with, even your most recent medical information. Even, right now we have all these interesting types of devices that can capture data about yourself, but it's completely divorced from, medical predictions and understanding, how you can be healthy and behave. And all of those things will have to be a decentralized type of learning. Otherwise, people will just be, it's not a particular, you mentioned Skynet and these sort of things. The last thing we want to do is have systems that we can't turn off. And so an important part of this is the collective ability of decentralization allows all of the world's companies to participate. It's interesting to see there's a big power law of the companies that can really operate in the AI space right now. There's only 3 or 4 or 5 of them. They're really pushing the needle. Everyone else is left out. So these methods will allow these companies to participate, and then most importantly, allow everybody else to opt in and opt out. And so we'll have models where even the inference, the prediction time of these models won't be possible unless there's a critical mass of people who say, yes, I want this to be able to be possible or not.
I love it. Beautifully said. Nic, thank you so much for breaking down a very complicated topic in a very lucid way. Really enjoyed it. Congrats on all you and your team has achieved, and definitely be following your work with great interest going forward. Thanks again.
Thanks so much. I had a great time.
Well, there you have it. Thank you again to Nic Lane, the co-founder and chief scientific officer of Flower Labs. Clearly, we'll have to have Nic back again on the show in the future. And thank you again to my partner, Vana, whose mission is user-owned AI through user-owned data. And this collaboration with Flower Labs is an excellent example of how this is actually coming to life. Finally, thank you to you, dear listener. If this is your first time at the People's AI, please subscribe. Apple, Spotify, YouTube, all the usual suspects. Tell a friend, tell your crypto friend who's in AI. This podcast is where these conversations are happening. Thanks again, and see you next time.